All right, guys, this is chapter 16, section 1, and it is all about water in the atmosphere. So here we go. The first thing is the water cycle, and we've already gone over this. You've had this in elementary school, so we're not going to spend a ton of time on it. But the steps are down there on your left. Number 1, water evaporates from plants and bodies of water. When it goes as water vapor up into the sky, the water will condense, which means it turns back to a water droplet up in the atmosphere, and those water droplets come together to make the clouds. Eventually the clouds get saturated. That means they can't fit any more water in there, the droplets are too big, and the water droplets begin to fall back down to the surface as some sort of precipitation. Once it hits the ground, it's going to run off the surface into lakes, streams, any kind of body of water. So let's talk about humidity for a minute. If you listen to the news, you might hear the weatherman talk about the humidity is 50%, or humidity, if it's raining outside, is probably going to be close to 100%. So humidity is the amount of water vapor that's in the air. Now, the percentage that you hear from the weatherman is actually called relative humidity. So the weatherman is taking the amount of water vapor that's in the air and he's comparing it to how much water that the air could possibly hold before it's saturated. When he divides those two numbers out, he gets a percentage, which is what he reports to you as 100% humidity or 50% humidity or whatever the number may be. Now, we measure it with the psychrometer. So that's the tool that we use to measure relative humidity. If you look, this is a picture of the psychrometer, and it basically is two thermometers that are hanging from a handle. One of the thermometers is just plain. The other one has this piece of cloth at the bottom that's actually soaked in water, so it's wet. So this is called the wet bulb, and then the one on the right that you see, the plain thermometer, is called the dry bulb. So what you would do is you would take a dry bulb reading. You would read the temperature on the dry bulb, and then you'd come to a chart that looks like this. So let's say that the temperature on the dry bulb was 22 degrees Celsius. Then your next step is to spin this psychrometer around and around and around. Once you've done that for a few minutes, you go and you read the wet bulb thermometer. So if we were at 22 degrees Celsius on the dry bulb, and then when we read the wet bulb, it went down 2 degrees. Then we come over here to our chart. We stay on the row for 22 degrees for the dry bulb. And then we go over to where we have a 2-degree difference. And where those two column and rows meet, right here, is at 83% humidity. So let's watch a quick video clip on psychrometers.
Relative humidity, or dew point, can be measured with an instrument called a sling psychrometer. We'll make one using 2 regular house thermometers, transparent tape, a clean cotton shoelace, water, thread, string, a pencil and paper, and a meteorology book that has tables called psychrometric tables. Place a piece of tape on the back of one of the thermometers where the bulb is. Cut a shoelace to about 1.5 inches and place it over the bulb of the other thermometer. Use a piece of thread to tie it to the bulb. Now place the thermometers back to back and wrap tape around them to hold them together. The tape should not cover the bulbs. Now tie a piece of string to the tops of both thermometers and cut it to about 3 feet long. Take a temperature reading of both thermometers. They should be almost the same, and the water should also be close to the same temperature. Carefully wet the shoelace without getting anything else wet. The thermometer with the wet shoelace is now called the wet bulb thermometer. The other thermometer is the dry bulb thermometer. Now you're ready to sling your psychrometer at a medium speed. Read the wet bulb thermometer every minute. The wet bulb temperature will fall. When the wet bulb temperature stops falling, write down the final reading. Also, write down the dry bulb temperature. It shouldn't have changed much. When you subtract the wet bulb temperature from the dry bulb temperature, you get a number that is called the wet bulb depression. Use your psychrometric table to locate where on the chart the dry bulb temperature and wet bulb depression meet. Depending on which chart you use, you'll either find the dew point or the relative humidity. Now you know how much moisture is in the air. It's important to notice in this experiment that the shoelace dries out because water evaporates into air. When water evaporates, the air cools, and that's why the wet bulb temperature fell. It's the same reason why you feel cool when you get out of the water at the beach.
Okay, so we'll do more with relative humidity on Monday. So let's talk about dew point for a second. Condensation is when that water vapor that's a gas turns back to a liquid, but it can't just magically turn back to a liquid in the water droplets. It's got to actually attach to something in order to go back to a liquid water droplet. So the cup on the right is cold. So as it cools the air temperature, the air right around that cup becomes saturated, and so the water vapor that's in the air in the room cannot stay water vapor any longer. So it attaches to the cup, and as it attaches to the cup, it turns back to a water droplet. This is exactly how clouds are formed. Obviously not with a cup, but the water vapor in the clouds attaches to pieces of dust, and then it can turn back to a water droplet. Now, the exact temperature when those water droplets form on that cup is called the dew point. So dew point is the temperature when condensation actually happens. So let's talk about clouds for a second. Like I said, clouds form when water vapor condenses or goes through condensation and turns back to a liquid water droplet. But like I said, it can't do that unless it's got a piece of dust to grab onto. So if the dust isn't up there, then you're not going to get any clouds forming. Not a problem. There's always debris and little tiny pieces of dust that are up in the atmosphere. So you're not going to ever have the problem of not having any clouds forming. So if we look at the different types of clouds that we can see that are up there, we have three major categories of clouds. We have cumulus clouds, which are the ones that look like huge puffs of cotton, and generally they mean you're going to have some pretty fair or nice weather. The only difference is that sometimes you have what's called a cumulonimbus cloud. Anytime you see that word nimbus stuck onto the end of one of the cloud names, it always means rain or storms. So the cumulonimbus are huge, puffy, tall clouds. Usually they're really, really dark, and you're going to get major thunderstorms with those. But if it's not a cumulonimbus cloud, if it's just a plain old puffy cloud, that's cumulus. That means you're going to have some fair weather. Stratus clouds are the ones that when you go outside, it looks like the entire sky is covered with one cloud. They go on for miles and miles. So generally you're going to get obviously some cloudy weather there. You're going to get maybe some drizzle if there's some moisture coming out of them. The other one, the third type, are cirrus clouds. These are the ones that are really high up in the sky, and they're kind of wispy. They look feathery, and generally they're not going to produce much precipitation with them. Pretty much fair weather. Okay. They are so high up, though, that instead of being made of water droplets, these are made of ice crystals. So if we look at this diagram here, it kind of shows you how all the cloud names and different types can be put together to form the various types of clouds. So on the right side, let's start with the cumulus. You see that over here we have a plain old cumulus cloud that is the associated one with fair weather. Now, cumulonimbus looks very different. It's huge, tall, and you're going to have black down here at the bottom because then the sun's rays can get through that thick cloud. You're going to have thunderstorms associated with that. Remember, there's your nimbus part of cumulo, so that tells you that it's a storm cloud. If we go over here to the left side, we have three categories over here. We have low clouds, middle clouds, and high clouds. So let's start with the low clouds first. Here are plain old names. A stratus cloud is a little puffy, but for the most part it's kind of short and wide, covers long areas. Here's a stratocumulus. So it's a stratus cloud, but it's a little puffier. Then we have what's called a nimbostratus cloud. Okay, again, rain cloud, there's our nimbus attached to it. If we go up to the middle layer of clouds, here's altostratus. Now, alto in Spanish means tall. So these are stratus clouds that are higher up in the atmosphere. That's where the alto comes from. And again, here's altocumulus. So alto means tall. They're a little higher up in the atmosphere, but they're still those puffy white clouds like cotton balls. And then we have our high clouds. Now notice these all have cirro as a prefix. There's your plain old cirrus clouds. Those are those wispy feathery ones. We also have cirrocumulus, which are the wispies, but they're a little fluffier, a little bit more resembling cotton balls. And then finally we have the cirrostratus. They're much thicker and they're covering a much wider area for the ground. They're covering more ground. So hopefully you can see how all these clouds can kind of be combined together to form what you might see outside when you look up in the sky. All right, so that's it for water in the atmosphere. Make sure that you have filled in your notes and that you bring them to class tomorrow.